And I'm live. That is pretty cool. And today is 15th of August 2025. What is the day? Today is Friday. And let's just begin doing solving questions at 1300 rating. And this is cool. This is cool. I am making progress. I did yesterday some questions. This one, it was like messing up with me, but I was finally able to do this. Right? I got it right. And wait, okay, yeah. After that, I was trying to do something else. So that is cool. And I did this one, strange birthday party. And this one was easy actually, not very hard. Yeah, I did this in 14 minutes, but I was unable to do this one. And I think this one is going to use dynamic programming, and I'm yet to implement efficient model for that. And this one was easy, but I was not paying attention, so I was unable to do this. Yeah, it took me longer than it should have, and shuffle 15 minutes, so that was cool. And now the next question for the day, and I am at the wrong place. Now I am at the right place, I hope. Yep, I am at the right place. And yesterday, the video I made, the stream that I did on my new setup was a tragedy because I was like just going through stuff and not explaining anything properly. So that is why I guess people make series on these kind of things. And yep, this is it. Stopwatch, not stopwatch, this topic. Stopwatch, and I will start my stopwatch and start solving the question. I can put this thing up. Problem solving mode. I will get into my problem solving mode, whatever that means, and go. Again, a presentation P of length. And overall, Let's see. Let's see how that goes. I think it will work. And yes, fuck yes. Okay, that is the fastest that I have been able to do any question till this point. 8 minutes 30 seconds, and I was actually gone. I was like, I didn't knew that I was streaming or anything. I genuinely forgot. Or 9 minutes. That was thrilling. And now I will move on to the next question. This one was cool. This one was cool. And let me actually explain this one. So in this question, I have been given an array, and I think I have done a very similar question, a question very similar to this one. Yeah, I think I have done a question very similar to this one. In this, I have been given a permutation, and here I have been given something like this, a permutation. And a permutation is that the size of the permutation is, let's say, 4, then that permutation is going to have every number from 1 till the size of the permutation. In this case, size is 4, so I have every number from 1 to 4, and every number appears exactly once, not less, not more. And yeah, so that is the point of a permutation. That is the like, that is called a permutation. And in this permutation, I have to remove some elements and then return a subsequence of elements, let's say like this 1 4 2, in which when I take the difference of any two given elements, it has to be maximum. It has to be as great as possible. And for that, I can depict this permutation like this 1 3 4 and 2. So given three elements, I would like to remove this one only when the difference between these two, which is this, and the difference between these two is the same as the difference between these two, between the first and the last. So this one is not really doing anything, and I can simply remove this one and get something like this directly. So I have removed one element which was actually not doing anything, and I can get this higher difference directly. And in when given three elements like this, there are only a few possible case scenarios. Either the middle one is in the middle, in which case I would remove, because this distance and this distance is equal to this one, so this one is not really doing anything. I can remove it. And one is this, but in this case, if I were to remove this, I would get this distance from here, uh, if I were to remove this. But if I were not to remove this, I would get, first of all, this distance and then this distance. So removing this strips me away from this much and this much distance, which I would like to have, since I want this quantity, the difference of adjacent elements, to be as high as possible. So I would not like to remove this in this case. And the third possibility is the same, when the middle element is greater than the other two, in which case originally I would be getting something like this, and if I were to remove this one, then I would only get something like this, so which is lower than these two, the sum of these two. So only in this case, when the middle element is in the middle, its height is in the middle, I would remove it, because it is not really doing anything. And in my code, that is what I'm checking. I first take in the whole array, and then I have initialized an answer array, and I would never like to remove the first and the last element, because that kind of makes sense. If I take that, because why would I ever remove it? Because let's say here I have at the second place, does not matter which number I have at the second place, and let's say at the first place I have y. So by removing this, whatever their difference is, x minus y absolute value, I am just losing this thing and gaining nothing. So I would not like to remove the first element, and the same goes for the last element. By removing the last element, let's say z is the last element, I would be stripping myself away from this distance and not really gaining anything. So I would always like to have the first and the last elements. And then, so that's what I'm doing in my answer array. I am adding the first element, and then I'm iterating from the element at index 1, which is the second element, going till 1 minus the last element, because I am adding the last element at the end. And for all the middle elements, I am checking if the current element AI, which I am at, is it bigger than the last element that I added into my answer array, and is this fact either it is bigger or smaller? Is it the same as the element which is next to this current element? So either if this current element is bigger than the last one and the next one, then this thing is going to be true because it is equality. And if the current element is smaller than the first one, then the last one and the next one, in this case also, this is going to be true because both would be false. And in both of these cases, I would be adding this current element to my answer, and then I'm just outputting the answer. So that is cool. 8 minutes is cool. So that was cool. Now I will be moving on to the next question. Let me also see. I guess greedy. Yep, greedy and two pointers. You could say, I guess. Yep, kind of. And tutorial. Do I have to read the tutorial? Let's see. Tilia, the answer contains the first element, the last element, and all the local minima and maxima. All the local minima and maxima. Makes sense, makes sense, makes sense. You can call these numbers local. Like here, I would like to have this number. This is local maxima, and here I would like to have this number. This is local minima. Makes sense. Where local minimum is an element less than 2. It's 2 adjacents, and a local maximum is an element greater than its 2 adjacents. Makes sense. And I can move on to the next question, which is going to be this. How long did you take to get used to focusing in silence without music? Without music, because I got serious about the things that I'm doing. And music is not always, but most of the time, you should not have music. Like it is like what David Goggins said. Music is at times distraction. And I guess you also know it, but just don't want to stop listening to it. But I do not listen to music, but I listen to edits. I watch a lot of edits of peak stuff like Peaky Blinder and Fight Club. Fight Club is cool. How old are you? I am 21 right now. So caring more or trying to understand that you are better without it. Yep. Yeah, you can say that. Yep. Caring more. I mean, you have to be serious about what you are doing, otherwise there is no point. Something like Martin Luther King said. Uh, for not living. Yep. Martin Luther King said, if there is nothing you are willing to die for, then you are not living, right? And if this is important to you, then can you like not just simply stop listening to music? And now focus time again. Shit, I had this thing on. My bad. Now focus time again. Okay. Okay, cool. I think this should work. This should work. Okay, I want to get this right in the first try. Shit. Shit. Yes. 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 Cool. Cool. Let's see. This should work. Should work. Shit. 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 It is taking too long. Shit. Okay. My bad. I will not look at the test case, which was wrong, because I should be able to get see what mistake I made right here. Shit. Shit. Is K inclusive? Is K inclusive? K should be inclusive. K is inclusive. Shit. I'm so stupid. Is there anything else? That seems like to be the only mistake. Yes. Yes. This should work. Es musste funktioniert. This should work. Okay, cool, cool, cool. 8 minutes, 8 minutes. Okay, that actually feels good to do these questions in 8 minutes. That actually feels good. Again, remove this thing, and that was cool. Shit. Okay, but I'm going to write 9 minutes because it was 8 minutes and 9 seconds. A little over 8 minutes. Shit. Okay, two questions for the day, right till now. And in this question, shit. But I shouldn't have, yeah, shit. I could have avoided this mistake. Okay, I will pay more attention to what I'm writing. Okay, so in this question, buying shovels, I have, this one was very easy. I guess this should not be here at 1300 level. This one was very easy. So I have been given two numbers, n and k, and k, okay, I want n things, and the things here are shovels. I want n shovels, and k and shovels come in different types. There are different types of packets in which shovels come, and there are k types of packets. One packet, and packets are different in the sense how many shovels they have inside them. The and given k, I know that there is a packet with one shovel, there is a packet with two shovels inside, there is a packet with three shovels, with four shovels, dot dot dot, till the largest packet I can buy is with k shovels. and I want n shovels in total. So in this, my goal is to buy as few packets as possible from these given packets, which is like, should this question does not deserve to be at 1300 level. This one was very easy. Why is it 1300? Number theory, maths, yep. So in this questions, it just means that I need to divide, I need to find the largest proper factor, the largest factor of n from 1 to k, and divide n with that, and that would be my answer. So let's say my n equals to 1000 and my k equals, let's say, 101. So the largest factor of n less than or equal to k in this case is 100. That is, I can buy a packet which has 100 shovels, and in total I need 1000 shovels. So the minimum amount of packets I can buy is 10. And if n happens to be a prime number, then I can only buy the packet which has one shovel inside of it, and in that case I would have to buy n packets. And if in some case n happens to be smaller than or equal to k, in that case I can buy a packet with exactly n shovels, and I would have to buy only a single packet. So that is cool. Number 3, and what does the tutorial say? Question D. Who did this? Step Pavli. 5 years ago. Question number D. Buying shells. This one was like, shit. This one was very easy. I guess how are ratings determined for a question? I don't know. If Polycarp buys A packages of B shovels and gets exactly n shovels in total, then A into B equals n. That is, A and B are divisors of n. Then the problem reduces to the following. You need to find the maximum divisor of n not greater than k, right? To do this, iterate over all numbers from 1 to root n inclusive, right? Inclusive. And yeah, I'm initially taking with m, and then I am iterating with 2 to root of n and inclusive less than or equal to, and check whether n is divisible by x. If so, then x or n by x are both divisors of n, and see if they are within our limit of k. And if they are, then choose the bigger one. So that is cool. I can move on to the next question now, which is cool. Let's see. And it would actually be crazy if I were to solve this whole thing, the whole remaining thing, but I might be getting ahead of myself. Let's see. No, refresh, and I will put up the thing, which is this, and get back to question solving. It has only been 35 minutes, and I did 2 questions, 8 minutes each, around 8 minutes each, 16 minutes, and it has been 35 minutes. I guess I spent 20 minutes in yapping around. Okay. I do not, I want to get this right in the first try. So A is the smallest factor because I'm iterating from the smallest number possible, which is 2. And after that, actually, I can do this. Yep. And so whenever I see a factor, AI is going to be, I is going to be the first smallest factor of n, and the remaining number that I want, B into C, B and C's product to be equal to A is going to be tar because n divided by A or I does not matter. And now I'm doing essentially the same thing and looking for the two factors of tar. But in this case, since I do not want the new factor to be equal to A, so I'm iterating starting from A plus 1 and going till under root of target. And I am not going to, and the under root square root of target is not inclusive, because if it were, and if tar happened to be a perfect square, I would not like to make J and then B and C would have equal value, and I do not want that. I want them to be distinct. And then whenever I find that current value of J is a factor of tar, and when I divide tar with J, and this would give me the value for C, and if that value does not equal to A, I already know that J is not equal to A because I am starting from A plus 1. I only need to make sure that the value for C that I will be getting is not equal to A. If that is the case, then I can just output A. I can say yes, I have found something, and A, J, and target divided by J, and then return. And if everything happens and I still am unable to find this, then no. And this could this result in a bad time complexity, because I'm going here like this, and I have a loop inside a loop. So if, let's say, n is a prime number, the biggest prime number in the given range, then I won't find any factors. That is cool. So, and if that is the case, I would never go inside this loop. But if, yeah, this should work. This should work. If it has only two factors or one factor, if it has only two factors, yeah, this is cool. This is cool. This is cool. It's fine. Maybe, but something does not seem right. Something does not seem right. J equals I plus 1. When I see that for the current, no, A should be as small as possible, because I would be leaving as big of a room possible for B and C. And if I come out and see that nothing is done, then I can break. I can successfully break. Can I? What if the factors are 2, 2 and 3, 3? I would take 2, 2, 2, 3, 3 and 5. I need at least 3 distinct numbers. Yep. Or maybe 2, 2, 2 and 3. Then 2, 4, 2, 3, 4. 2, 3, 4 is also okay. By taking the first value of A, the smallest value for A, I'm leaving the biggest room possible for the target, which is cool. Therefore, I can break. Yep, I can break. I can break, and this should work just fine. And I have spent a lot of time just making sure that I get this right, because I want to get this right in first try. which which I do. Shit, fuck yeah. Okay, 12 minutes for this one, which is cool. And why do these problems seem very easy? All of these three problems were like maths related, factorial and stuff, and not factorial, but factors and just simple maths things. And these are very easy, so that is cool. And now I am back from that mode. And now I would like to explain this question, even though no one watching. Yeah. So that is cool. 12 minutes is cool. So in this question, show tags, it would say number theory and yeah, number theory, maths, greedy. That is why I wanted to choose the smallest value possible for a greedy. And let's see, accepted what is in the tutorial for this question. And here we have this thing. Should I have seen this guy? Not like actually seen him, but I have read his name before. And he does contests. That is cool. Product of three numbers. This was very easy. Suppose A is smaller than B is smaller than C. Let's try to minimize A and maximize C. Let A be the minimum of divisor of n greater than 1, then B be the minimum divisor of n by A that isn't equal to A and 1 if n divided by A into B isn't equal to A, B and 1, then the answer is yes, otherwise the answer is no, and that is what I'm doing. That is cool. That is exactly what I did. I am just finding the first factor for n, and then my remaining target is n divided by A, and then I am iterating and finding good suitable values for B and C in this case, which is this, but the thing that is written in the editorial is much better than this because they are looking for the smallest value for J, and if it is not equal to I, they just, if it is equal to A, they just skip. So instead of this, I can do this. If not equal, if target divided by J is not equal, and I know J is not equal to be going to be equal to target divided by J because I'm not going till under root of J under root of target. If this is not equal to A, then I have found my answer. Else, break. I will break out of this loop, which means I will come here and break out of this loop and I will output no. That is cool. And now I would like to move on to the next question. I've done three till now, which is very cool, and the watching is also amazing, and I can put this thing up, which is fine. And now I will start doing this question and start my timer and drink a bit of water. Focus mode. Yep, focus mode. Okay. Okay. Shit. Okay. This is Cardane's theorem. Timer is going on. Okay, my bad. I can use Cardane's theorem here. Shit, I forgot how to apply Cardane's theorem, but I can figure it out. Garden's theorem, Garden's algorithm, and this should also be correct. Okay. I thought this would work. Okay. Mm-hmm. Okay, this is the thing. This is the thing that is messing up. Everything else is correct. And I can fix this. Alright, cool, 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 cool. Shit. Okay. Submit, and now this should work. Either the sum of the whole thing is greater than the maximum, and if it is not greater than the maximum sum that I have gotten, check if it includes the whole array from the from the leftmost element to the rightmost element, and either of those are true, then yes, otherwise no. Because if I had any subsequence whose sum was greater than sum, I would have chosen that, but I didn't, so this is the maximum sum. Okay, cool, submit. Yep, this is the maximum sum. Okay, now do I hope? Okay, okay, okay. Okay. And yes, that does work. That does work. That does work. And I don't know why it didn't work there. Okay, let me read the question again because I do not want to get this wrong 3 times in a row. Today, answer RL at the shop, cupcakes there are and types. If there is a subsequence which I can choose which has a greater than sum, then this thing. So this should work. This should work. This should work. This should work. In this case, I equal. Yes, in this case, I would get equal. In this case, also it would be no. And okay. Let's see. Let's see, and hopefully, it will work. And I would have to see why I got wrong answer on test 2. And it, okay, so this is accepted. That is cool. 22 minutes is a very long time. Shit, no, 22 minutes is bad. And I have already done one question. One, two, three, four questions for the day. That is very cool. And how much time has it been? It has been 1 hour and 13 minutes and 4 questions. That is a good average. Refresh and they will become green. That is cool and actually cool. And why did I got wrong answer on test case 2? I do not want to look at the test case on which I got the wrong answer. I only want to look at my solution, what I submitted. What is wrong with this thing specifically? I'm taking in n, then I am taking in all the input and summing them. That is amazing. And then I'm taking in and then like classic Cardin's, not Cardin. I guess it is Cardin's algorithm. Yep, it is called Cardin's algorithm to find the maximum subarray sum. Yeah, subarray subproblem. And how much difficulty does it say it is on lead code? It is a medium level question. Okay, maximum subarray. And I have solved this. No, I don't have any solutions. Shit, I can do this right now. Actually, shit, I have solution here. Like some what am I doing? Why do I have? Okay, okay. That makes sense. That makes sense. That makes sense. And this should work. Wait, network error. Is my stream fine? My stream is fine. It is because I have to relog in. Yep, I do have to relog in. And I have logged in. That is cool. And now I can, it should say, yep, was this? Yep, this was good. So, okay, this is called Cardin's algorithm, which is used to find the maximum sum in a given array, maximum sum subarray. And in this, I am applying, I have a current running sum and a maximum sum, and I have current left, that is the subarray that I am currently considering, its left index and the left index in general, right? The left index of the maximum subarray. So whenever I see that, I should choose the current element. Yep, that I should choose the current element over adding this current element to whatever the series has been. In that case, I update the current left to be equal to the current element because I'm starting my new series from the current element, and my current maximum would become equal to AI. And else, if that is not the case, then current maximum plus AI, the current element. And if at any point I see that the current maximum is greater than the global maximum, then I update my left to my current left and my right to whatever the index I am currently at. Then I am outputting yes, that is when either sum is greater than maximum, either sum has to be greater than maximum, or both the limits of maximum and minimum equal are at the ends of the given subarray, are at the ends of the given array. But there is something wrong with this somehow. This doesn't give the right answer. Either this or this. And in both cases, output yes, otherwise output no. So either my maximum is equal to my sum, right? And if maybe, shit, yeah, I'm only updating my maximum when the current maximum is like that. Yep. makes sense, makes sense, makes sense, makes sense. What if by choosing the whole array, I get the maximum sum, and also there is a sub-array in that whole array which also has the same maximum, in which case, yep, this was the thing that I had, and this was the thing that I had, and I would like to fix a few things here. If, even if I see this, then do this, right, then do this, and here, even if they are equal, then do this. This should make things better, and I would like to see if this works now. And it should. Is the thing still up? Nope, the thing is gone. This should work. This should work. Nope, this doesn't. Okay, I would have like to see the test case, or maybe not just yet. Diagnose this a little bit more. Even if AI is equal, right? Which means CMX at some point equals 0, right? Else, this, right? CMX greater than equal to maximum, even if it is equal, update the left and the right thing, and either my sum is equal to this or the maximum that I have gotten includes the whole array. L equals to left and R equals n minus 1. But this does not work. Okay, I would look at the test case now, even though I got this right. Wrong answer, expected no in the sixth token. Sixth token is 1, 2, 3, 4, 5, 6 in this one. Here, this thing is 300, and including this is just 0. Wouldn't be good. Right, so adding this 50, I would add this 50, and then yeah, my maximum would be till here. But when I go back to this thing, let's see in this test case, what are my left and right values? Why am I messing up? This should work. This should work. In the first, when I equals 0, AI would be equal to 100, and I would update CMX, and CMX would become equal to 100, and current left would become 0, and maximum would become 100, and left would become 0, left would become 0, and right would become also 0. And then yeah, current value of maximum would be 100. After that, when I come back in the second iteration, when I equals 1, I would still have 100, and 100 plus 100 is okay, in which case CMX plus this thing would happen, and which would be greater than maximum. So L would still be 0, and R would become equal to 1, and in the next iteration CMX would become 300, L would remain 0, R would become equal to 2, right? Cool, and MX equals 300. And then I would get a minus 50 minus negative 50. which is cool, which I can add to this thing, and current left, which I can add, right? Which I can add. So current left would still be 0. But this time, current, yes, I would go into this, and AI is minus 50. So yes, and 250 is not greater than or equal to maximum. So cool. But then in the next case, CMX would become 100. Makes so much sense. Yep. Yep. Makes so much sense. Makes so much sense. And yep, because this would be equal. Yep, this would be equal. And I do not want that. Makes sense. Makes sense. Okay. So that is why this should not work. And instead, this thing works. I am iterating twice, and I would like to see the editorial in that are they also applying a loop twice, which is making the time complexity equals 2n in the tutorial. For question number B, for the question number B, just eat it, right? Yep, just eat it. The candies. If there is at least a prefix or suffix with non-negative sum, we can delete that prefix, suffix, non-negative sum and add and end up with an array with sum greater than equal to the sum of the whole array. If there is at least a prefix or a suffix with non-negative sum, we can delete that whole prefix or suffix and end up with an array with sum greater than equal to the sum of the whole array. So if there is this case, then the answer is no. But you are saying that the sum of the prefix and suffix is non-positive. Okay, if it is non-positive, then cool. Then we are cool. Then we are actually cool. Shit. Okay, is that what you're looking for? Going from the left ones and going from the right ones and seeing if there is a non-negative sum at any point, non-positive sum, and that is either 0 or negative. Otherwise, all the segments that Adel can choose will have sum less than the sum of the whole array, because the elements that are not in the segment will always have a strictly positive sum. So in that case, the answer is yes. And they should be applying two loops. Yep, they are applying two loops from the start till the end, and if at any point sum is less than equal to 0, then return 0, and if this, then that is cool. You can do that, makes sense. Yeah, that is cool. And now I would be moving on to the next question. I can put this up, restart, and move on to the next question, which is balanced tunnel. Balanced tunnel. I have like Peaky Blinders music going on in my head throughout this stream till this point, which is crazy. Okay, cool. Find the number of cars that must be fined. Pairwise distinct. That is crazy. What does that even mean? Two makes sense. Okay, all of this is very bad. Okay, hopefully, but I should not hope, should I? Like I said, shit. Okay, shit. Yes, shit. Okay, makes sense. But I do not want to count the same cars again and again. Wait, this is wrong. Shit. Okay. Okay, I need to find some inversion, something related to some inversion in this. If this is the sorted order, if I'm supposing that this is the sorted order, then how many inversions there are in this, which is the same as asking, nope, nope, not just the number of inversions. Yeah, which is the same as asking if I were to use bubble sort, then how many swappings would I have to do to make these two array similar? And in this case, I would have to do two swappings. Put this. Shit. Not two swappings. Swapping is a bad example. Swapping is not good. And I can put a restriction on swapping. In swapping, I can only put an element from the left to any place on the right. So I can put this 4 from here at the end, and I can put this 2 to the right of this 5, and these two sequences would be same. And here, to make these two same, I would have to put this 2 to the right of 5, this 3 to the right of 5, and to the right of the 2, which I just put there, and do the same for all of these 6 elements, therefore 6. And here I do not have to do any swapping. But how would something like this work? I can create two maps, and then have the order for both. Nope, nope. Okay, for a particular element that I am at, I have to ask myself, how many cars has this element taken over? Or yes, and in here, if this one hasn't taken over any car, any number of cars, because this cannot take over any car. Or nope, that is not a good example. Here, if I had 2 and on the left there is only 5, so for 2 to overtake any car, the only option is 5, which 2 did, and 5 is on the left, but I do not want to check every element with every element on the left. For example, if here is 6, 6 has 3 available options. I do not want to check how many among these 6 overtook, because that would increase the time complexity to n square, and I cannot afford that much. It just takes 1 second. I can use a lot of memory to do that. Just find the number of operations, the number of swapping operations it would take. How do I do that? I can store in a map address of all of these elements. Wait, I said that I can take one element and put it on the left at any location, and that would count as one swap. So, shit, I can take this array. No, that would still not work. That would still not work. No, it would. What if originally I had something like 1, 2, 3, 4, 5, 6, and 7. This one is at the middle, and let's say when they come out the other side, I had this sequence 5, 6, 7, 1, 2, 3, and 4 is still in the middle. If this thing works for this, then everything is cool. I will check 5 and see it is currently at index 0, but originally it used to be at this index, which is index 4. So I need to take this to the left, so increase my counter, swap counter by 1. This thing, this I also need to take to the left, so +1. This thing I also need to take to the left, so +1, and this thing, no thank you. And when I have, where would I like to take these, right? I can keep a count. Do I just take them to the leftmost place or to some place in particular? No, I would not like to take them to the leftmost place because that is bad. That is bad. In this question, the answer is car 4 overtook all of these 3 cars. So 3 for that and plus 3 for these 3 cars because they overtook 4 and all of these cars. So 3 plus 3 in this answer is 6. But how do I get to an answer of 6? I would not like to put these elements at the end because that is bad. I If I were to put this element, where would I put this element? I would like to put this element to the right or to the left of the elements that it originally was at. No, this is still bad, not good. In this sequence, yeah, I can do this in this sequence. I don't know who this one single guy is who is watching my video. 1, 2, 3, 4, 5, 6, 7. This was the thing originally. Then let's say this car overtook all 3 of these and went there. I want to reverse engineer this, right? After this, I had 1, 2, 3, 5, 6, 7. So I would like to reverse engineer this thing. And to do that, I need to put this car to wherever it belongs. Now, if I could just look at a car, and for this car, I have to see, for every car here, I have to see how many of these cars are not in the list right now. Wait, I can have a set. I can iterate through. Okay, when I have this number here, what do I want to know? Among in this range, how many cars have overtaken? I will have one one here because this one has overtaken 4. This is not in this set, so that is bad. Then I extend my set over here and here, and I add this element, this number, to the set, and the size has increased by only one. I have only added one new element, which is 2, because one was already there. So that is among the elements that are in the first nth place, how many are supposed to be there and how many are not supposed to be here? That is a question I can ask myself. Okay, that is a very good question that I can ask myself actually. Let's say in this one, I can create a set. I can create a set actually. And how many sets would I need? This and this array and this and this. And while traversing, I am asking myself this set that I currently have of the cars who have exited, how many are not supposed to be here? There should be only this one car whose number is 5, but that is not here. Here I have 2, so this 2 must have overtaken some cars, so +1. Then I extend my set to include 3. Here in the original sequence I see a 2, and the difference, I will keep okay, I will only keep one element which will start with the first element 5, right? And then I will take this element and append this element to my set. Then my set would have 5 and 2 elements, and I would see when I added this element, did the size of the set increase? And if it did, then my set has an element which should not actually be here. And then when I go to the next index, I would add first of all this number, and then I would add this number and see. Now, does my set, did the size of my set increase? And it would not. It would actually, it would because now I have 3 elements in my set. 3 also is there. And after adding this 2, the size of my set did increase to 3, so that is cool. Then I would add 1 to my answer. Then I would go here, add this 3 to my answer. My set would be just this. Okay, what is the invariance that I can leverage in this? When I'm starting with 2, 3, and stuff like that. Increase the size, playing with this. Okay. Here I will have a running set in which I would first add this number and add this number. So at any point, let's say I have gone till here, then when I go to this index, I will first of all add this thing. I will first of all add this thing. Therefore, my set would either, and I would also have added all of these elements which were here. So at this point, I have a set. My set includes every element in this thing and every element in this thing. And at the end, the size of my set would be 10 to the power 6, which is fine, I can have a set that long, which is fine. So when I add, so at this point, before adding this element, my set would have all the elements which are supposed to be here at this location, and all of these elements also which are not supposed to be here. And if I add this new element into my set and the size of the set increases, that means I have added an element which is not supposed to be here, which means this is messed up. And I would increase my counter by 1. But what if my set was something like this: 4, 5, and the cars came out like this: 4, 5, 3, 1, 2. So initially my set would be this, and adding this would increase the size, so 1, and then this, and adding this this element would increase the size, so plus 1, and then adding this and then this would not increase the size. So that is cool. And what does that mean? That means that in here, in here, I have two elements which are not supposed to be here. And then when I go here and here, nope, this is bad. This is wrong. This is wrong. Because this car overtook these two cars. So plus 1 for that. And then these two cars overtook all of these three cars. That is why they are at the front. So answer should have been 3. But it is 2. Because when I go further and add this and this, they are not going to do anything. So maybe I should create two different sets. One set for this and one for this. And I would comparing two sets is a bad thing. Comparing two sets is a bad thing. So instead of comparing, yep, comparing two sets is a bad thing because these things are tricky to catch. This 3 did overtake these two numbers, but two other numbers overtook the 3, and now 3 is back at the place where it was. So the order matters. 45 minutes, that makes sense. This current element. Asking myself, does this current element belong to the elements which have been till this point is bad because of elements like this? So should I ask myself two different questions? Uh, what does overtaking mean? When a car overtakes another car, then it would only be possible to overtake if, first of all, there are cars on the left which could be overtaken, and if this car has overtaken, then this car would be to the left of either this, this, or this element. One of them has to come to this number's right, and that would mean that this car has overtaken, and that I know by considering the order. But to do that, I do not want to go through the whole array. Here, actually, the answer would no. I just need to see if this number has overtaken at least one of those cars. And if it has, then okay. And it seems like there is some concept that I should have known, but I do not know. Something something like inversions in a loop, something like inversions in a normal loop is what I need. but not even that. If I were using bubble sort, then how I no, that is still bad. That is still bad and would not work. Yep, that is still bad and would not work. It would actually be very bad. Okay, now I think I can look at the tutorial or something equivalent. It has been 47 minutes and shit, I just feel like, oh, no, okay, no, I will not look at the tutorial because I just feel like I can just do this. Okay, I will come back to this question later because I think I can do this without looking at the tutorial, and I will think about it after the stream. And instead, since I have done 4 questions, I just have to do at least 1 question, and that would be the end. And it has only been 2 hours, which is cool. 2 hours is cool. I'll restart this, and yep, the thing is off. So that is cool. Wow factor. Okay. Okay, I have to calculate something called the wow factor and question mode. Shit. Okay, I just have to go to the washroom and I will be right back. I can, no, I can stop the time. I'll be right back. Yo, yo, I must be audible now. And I'm back. That is cool. Okay, in this. The wow factor. The algorithm that is coming in my head is n square, which is bad. I'm trying to optimize that. For every new w that I see, I have to pair it up with every w that has been, and that would be easy. That would not be very hard because I can create a vector for storing w's and a prefix sum vector for storing all the o counts. But w, and the fact that two v's could be combined to make a w is also not very bad. It is manageable. But n square is bad. I have to find an algorithm to solve something like this, exactly like this efficiently. O, W, O. These two W's could be paired, then these two could be paired, and these two could be paired. And the number of O's the number of choices for O's I have between these pairing is also different. Then these two could be paired, and these two, and then at last these two. Now I have paired every single W which could be paired to make a 0 and to make a wow. But the thing is, it is going to take n square time complexity around if this is the input that I get. And this is bad. So I need to find an optimal way, a better way in which by which I can do this. Pairing up numbers and figuring out something for them. When I'm pairing this with this, I add all of these possibilities for using a 0, for using a O, and multiply the number of W's I can choose from this side and multiply that by the number of O's I could choose. Well, or I could think about this in terms of what possible values of W's do I have which I could remove to get an answer. That is for this, I have a choice. I either add this or I don't add. If I add this, things would be different. Things are not like that. No. I could include this or I could not. Same goes for this. But only in a subset. Okay. When I am at this point, the number of possible answers would be this into this into this. And then whenever I encounter a new W, I have to pair it up with every other W that I have seen. And that is going to take n square time complexity, which is bad, which is bad, which is bad. So I need to fix this thing, and I can use a lot of space, I think. 256 is fine. So maybe something better than this, something better than this. W into O into W into O into W into O into W. Bah. I am fine. How are you? Well, I'm not actually very fine. I'm unable to do this question, which I have to do, and I will do this. I will do this. Shit, that is too big. Okay, so the problem is just this. Whenever I encounter a new W, I have to pair it up with every single W that has been in the past. And that is hard. Not that doing it with brute force is hard. Brute force is easy. I can do that. But how do I optimize it? I was able to do those four questions, these right here, very quickly. They implemented some maths, and I think I have fine maths. My maths is fine. But these two questions I have been unable to do because this one is using permutation and probability and something related to that, but that is bad. My permutation is not very good. Permutation permutation combination. Permutation, can I apply something? I have to apply a combination because W's are W's. Okay, and okay, I could say that I am taking this W at any given point. I have to just from this whole string choose two W's and a single zero, right? W O W O W. So at any given point, I have to choose one W, two W's, and one O to make it wow. But when I am choosing these two W's, I can only choose this O. I cannot choose any of these because they would be outside. So, uh, so when I am in this range, let's say I am here, then I would see how many O's are there in the middle of this thing, and how many W's are there in the middle of this thing, and find the possible combinations of all those W's and all those O's and keep it somewhere. Let's call it X. Then I would move on to the next W I see, and I would see here I can choose two possible O's and three possible W's. But when I'm choosing this, I do not want to choose this, which would be included in the answer, but I do not want it to be included. Yeah, this is bad. This is bad. Okay. Optimize. Should what? Oh shit. Okay, this stopped earlier. Mm, I need some kind of optimization on this thing. Okay, I need some kind of optimization on this thing. And do I understand the problem? Yes, I do understand the problem. I just need to pair up every single W with every other W. But that is a lot of pairs. If I have, let's say, n W's, how many pairs can I make? I can make in total I can make n into n minus 1 divided by 2, this many pairs. If I have 5 W's, I would be able to make 10 total pairs, and in this case I have 4 W's, I would be able to make 6 possible pairs, and they would be something like this W with this one, then this again with this one, and then at last with this one. That is 3 pairs, plus I start making pairs with this one, with these two, and then this one with this one, so plus 2, and at last these two plus 1, that is 6. So that is the number of pairs I can make, which is like n square, because n into n minus 1 is almost equal to n square, and it is time complexity n square. But I want to avoid that. N square is going to take a lot of time, which I cannot afford, and I can remove this thing. I am in Matha. Yep, maths. Yes, this is maths. Permutation, combinations. I don't even know if you would. Nah, we are not using permutation. We are in some sense using permutation, and in some sense we are using combinations, because I have a bunch of W's in a row, and then a bunch of O's in a row, and then a bunch of W's, and off to the right some new O's, and then a bunch of W's. And given this is bad. This is not even like a normal permutation combination, because there is some restriction to the choices that I can make, because when I'm choosing this set of W's, one of the W's from this set, or one of the W's from this set, I only want to choose O's from this set and not from any other set. And brute force is bad. Brute force is bad because someone can give me as the puzzle input something like this: W O W O W O W O, a very long string which has 10 to the power 6 characters, which is shit, that is cool. When I closed this, the color inside this changed. Shit, that is pretty cool. Okay, after back to the topic. I cannot do this. Shit, not anymore. Magic is gone. Okay, that is a distraction. That is not the main thing. The main thing is to find an efficient algorithm. And do I understand my problem? Yes, I do understand my problem. I can ask ChatGPT. So this probably uses some mathematical or computer science trick which I am not familiar with. So I will not ask ChatGPT for the whole question. That would be bad. But I can ask ChatGPT to help me in the thing that is like very specific and very tangible and very is to the point, and not saying just help me in my whole question and here is the question. That is bad. So my problem is this: I want to pair stuff up, and when I'm pairing this with this, I can instantly find the value for these things. Yes, because I will keep track of the number of O's in between, and then I would just have to multiply the number of O's with the number of W's on this side and with the number of W's on this side. That would be give my answer. And if I'm pairing this W with, let's say, this W, I would know instantly the sum of these three O's using prefix sum, which is pretty cool. I can use prefix sum, and to this point I have been thinking maybe there is something similar to prefix sum in case of multiplication, but I do not think, because I do not think so, because this is not good, because this is not good. Nope, nope, because here when I'm pairing this thing with this, I'm excluding these two w's in the middle, right? So that is bad. Okay, I have a CS algo problem in which I have a set of elements which I have to pair up and then find the value for, and then calculate some value based on those pairs, uh, the value finding process is constant time, but the pairing process is the bottleneck, and I want to avoid it. Is there some way to speed up the pairing process? All right, pairing, and I have not given ChatGPT the specific question. I am just asking a little problem that I have, which is cool, which is not cheating, which is cool. Pairing elements into disjoint pairs, pair elements with every other element, all unordered, into disjoint pairs, which has a lot of pairs. Shit. Okay. Ways you can speed up. Case A, all unordered pairs. No, by ordered by unordered pairs, they mean that in a set, not every pair of element has a value which is can be used to determine their order. That is an unordered pair. I think that is an unordered set. And there is also a set like P set. If you cannot change that requirement, then the only speed up is avoid storing the pairs, generate them on the fly. Nope, nope, nope. I am not trying to save memory. I'm trying to save the number of operations that I'm doing. SIMD, I can use simple instruction multiple, a single instruction multiple data set, but okay. Find an optimal pairing based on value function. Based on value function. Don't generate all pairs at all. But I do have to generate all pairs, so ChatGPT does not get what I want to ask. Oh, W, O. Pairing is going to take time. Pairing is the only bottleneck. Even if I iterate, I have to see this. Whenever I see a W, I have to pair it with every other W that I have seen till this point, which is a bottleneck. This with this here, and this with this. Okay, let's actually calculate the whole thing and see if there is some optimization that I can finally make. let's call this W1, O1, W2, O2, W3. Let's have 4 things. Now the magic is back. W4. Okay. When I am here, I cannot pair this with anything, but when I am here, I can pair this with this and this, in which case I would have W1 into O1 into W2. Then I move on to the next W that I have, and I can pair it with this and with this, in which case, let's say this was my first term. Now I can pair W2 with W3 dot O2, possible number of O's or zeros I can choose in the middle, plus W1 into W3 into O1 plus O2, because the choice for number of O's I can choose has increased. Now add to this. Now when I encounter this, I can pair it with this, and also with this. So W1 with W4, I have a bunch of O's, O1 plus O2 plus O3. That is the number of O's. Plus when I pair 4 with 2, I will get W2 into W4, and yes, my writing is pretty amazing. And O2 plus, yes, O plus O3. And then finally with W3, W4 into W3, and in this case I only have O3 possibilities for choosing O's. And now given this thing, could I have gotten this without making all of those pairs one by one? For which I would have to open this whole thing. Okay, and I should use this instead of writing it by hand. Okay, here I have W1 into O1, capital W1 to O1 in O1 into W2 plus W2 into W3 into O2 plus W1 into W3 into O1 plus O2, and now plus W1 into W4 into O1 plus O2 plus O3. Then I have W2 into W4 into O2 plus O3. Yep. Plus W4 into W3 into O3, and I can increase the size. And thanks for letting me know how to use ChatGPT. That is cool. Thank you. I don't have to say thank you. I have to say welcome. And okay, here is there some optimization. I can take W1 common from three places because there were elements till W4. So I can take, let's try to do that. I can take W1 common, W1 into O1 into W2. This does not feel good. This does not feel good. Nope. No, no, no. Nope. Doesn't look good. Maybe I should try to open this bracket, in which case this would become multiplication, and here I would have an addition this thing. And if I open this thing also, here addition and multiplication. And now we are out of the screen. Peace. Okay, that is cool. That is all. And now, are there things? I guess I can take them common on the basis of O. Like, yep, let's do that. So if I take O1 common, then I have W1 in, into W2. And what I'm trying to do here is seeing if there are some operations which I can avoid repeating into W3. And there is O. That makes sense. Whenever I have O1, I would always be using W1 with it, because if I am using W1, then I would, if I am using W1, then I always have the choice to use O1 with any pair. Does not matter if I'm pairing with W2, W3, W4. If I'm using W1, then I would always have the choice to use O1, which is cool. Uh, that is why for O1, I am always seeing W1, and I think the font might be a little bit too small, but yeah, like the equation is big. And okay, that was the second O1. Now I had O1 there. Yes, plus, and are there any other O1s? Nope, there are no other O1s. And does that make sense? I have only three W's and W pairs and with which I can use O1. That does make sense, because I can use this with this, or this. Makes sense. And the next W and the next O, I can pair this one with this. I can pair this with anyone. But when I am pairing this with this O with this W, I can on the other side choose these two. And when I'm pairing with this, then on the other side, still I can choose these two. So 2 into 2, 4. That is cool. I think I'm moving in the right direction now. And I just do not want to look at the solution just yet, because I think I can do this on my own. W2 into W3, and plus when I am using W1 into W3, then plus when I'm using W1 into W4, and add to that W2 into W4, W2 into W4, and that would be it for O2. And then for O3, I can, what can I use? I can use, yes, W1 into W4, then W2 into W4, plus W3 into W4, and that would be it, because that is it, like literally it. I only have O1, O2, O3, and I have taken them common. Now, is there some optimization that I can do here? Are there pairs which are reappearing? Shit, yes. Are there pairs which are reappearing? I can bring this here and actually increase the size, which is cool. Okay. No, no, no. Even if yes, shit. Since I want to reduce the number of pairs that I am using, I would not like to do this, but maybe internally I can, in this case, actually I can take W1 common. I can take W1 common in this, and in this I can take W2 common from this and this thing. and W1 common from this, and this thing makes sense. And in this case, I can take W4 always common. So let's go with that. So when I have O1, I have taken W1 common, and inside I am left with W2 plus W3 plus W4. Add to that O2 into W, and I think this should become W2 into W plus, shit, I think I got this. Okay, W2 plus and W1 1 plus W2, this whole thing into the sum on the right, which would be W3 into W4. Okay, and then I would have W03 multiplied outside. Okay, on the left I would have W1 plus W3, W2 plus W3, the whole thing multiplied by W4. Okay, so shit. Okay, I got this. I can start iterating through all the O's. Okay, I can start iterating through all the O's. For O1, I have to choose the shit. This should have been obvious to me. Fuck. Okay, for O1, I have choices on the left which only comprise of W1, and on the right I only have this much choices W2 plus W3 plus W4. For O2 I have W1 and W2 on the left and W3 and W4 on the right, and for O3 I have W1 2 3 on the left and W4 on the right. And this proves that I am stupid. This was obvious. Okay, shit. Shit, yes, this was obvious. I was trying to iterate through W, but instead I should have iterated with O's. You're making this question more complicated. Yes, for each O left. Yes. Now you just need to find left and right in W, but how is the question? And you know the fact that two consecutive V make W, so compute those. Yep, I can just count the number of V's I have, and number of V's minus 1 is the number of W's I can get from a given amount of V's. And if at any point I encounter a single V, that just means I have 0 W's there, because V minus 1, 1 minus 1, 0. And you seem to know the answer to every question that I do. What is your rating? I am very curious to know your rating. And I can solve this one now. One a plate, two and one, and nope. I only have a spring. So shit. This one now, in hindsight, seems very simple. Take the string and then the number of W's. Yes, I would have to store them in some array. Yep, and I will iterate twice. Once to get everything that I want, once to have a prefix sum, to create a prefix, and second when I am actually calculating the answer. Vi W, right, and Vi O, and the size of O would be lower than the size of W. And if I'm seeing I do not want to use O's from the start and from the end. So for int I equals 0, I less than s dot size I plus plus, and if si equals O, O, and are they capital? or not? Nope, they are not capital. That is cool. If this is a O, but I need to see am I encounter. Well, that actually does not matter because on the left I would have 0 W's to pair this up with. So that is cool. That is cool. That is cool. And when I'm doing this, I think I can do better than doing this, creating a vector, because for every O I need two things. I just need two things, the number of W's to the left and the number of W's to the right and the value of O. So I guess I can use, instead of this, W left, the number of W's on the left for the current O. And whenever I encounter a O, I will just append it to, I will append it, right, uh, at the last of this O. Yep. But I have to see, and this cannot be, yeah, this is fine, this is fine. Whenever I see an O, I would like to add it to the last O. Okay. Int CO, current number of O's, and CW, current number of W's. But this could be bad because this could be bad. Whenever I see a W, I will fix that. Yes. Whenever I encounter a W, I will see how many O's I have. I will add that number of O's to the left and to the last O, and makes sense. So whenever I see a O, all I have to do is current O plus plus, which is initially CO and WO both are equal to 0. Else, if it is a W, then there are some stuff I would like to do. Initially, yes, so I can add W's on the left dot push back current W, the W's that have been for the last O, current W, and for O dot push back current O, the number of current O's. That is cool. Current W and current O. Mine is 1452. Max is 1583. And bro, you cannot find equal to V count 1. Why? I think I can. That should be true because I have to choose consecutive V's, right? To make a W, I can only choose consecutive V's. Therefore, for this thing, I can make this W, this, or this, and I cannot pair any of this V with this. That is bad. See, this and this does not count as a wow because I cannot pair this V with this V, right? But I do not understand what this line means. For a given string S, compute and output its W factor. Note that it is not guaranteed that it is possible to get S from another string replacing V with W, with replacing W with V. For example, S could be like this. That makes sense. That makes sense. uh, when I'm using V's, I could have something like this. Wait, shit. A V represents the wow factor for this would be, yes, I can use, it's, it is fine, it is fine. The number of V's minus 1. The number of V's minus 1. Yes, from this thing, I can only choose this as a V, this is same, this or this as a V. That is cool. And if I encounter something like this, then I cannot choose any V. And whenever I see a W, I do this, and current W would be 1 and current O would be 0. If current SI equals 0, I see a O, I increment, increment, increment. This might be the first O that I see in the whole string, or this might this O might appear before any W, in which case I would be adding to this thing some amounts of W, some amounts of O, and 0 amount of W, which is fine, which is okay, because when I iterate on the left, I would see that there are no O's, and cool. And whenever I encounter a W, which, so that takes care of the fact when I have my string starting with O. But if I have my string starting with W, I would add 0 0 to both the things, because both of these are 0, which is also fine, which would just increase the problem iteration by 1. And then going further, at the end, my string might end with O's, in which case I do not care about those O's. But if it ends with W, I would like to see, I would like to add, no, I can keep a total running count of the number of W's, the total number of W's, right? Yes, running count for the total number of W's would be cool, because I can just subtract the W's on the left from the total W's to get the W's on the right. So that would be cool. That would be cool. That, that would be cool. That would actually be cool. So int tw equals initially 0, and whenever I see a W for the first time, that is the last one was a O, only then I want to do this. So how do I see if the last one was last time I saw an O? Int LO last O equals true. So if LO, if the last time that I saw anything it was a O, then wait, what? Bool LO equals last O equals true, and that makes sense. Is I am supposing that I am starting with O, which is fine, which is not bad. And here, if I see last O was true, then I would like to do all those push operations that I did, which is W's on the left, push back to this current, not just current W, the current running count of W's, the total count of W's, which is TW, not just the number of W's on the left side. Yeah, the total running count of W's that I could choose. Okay. Messages get retracted due to some reason, right? I cannot pair this W with this. Yep. And whenever I see an O, I can do this. I think I might be doing something very, very wrong here, but that is fine. I will fix that. Hello, and at the end, hello equals not hello. And this is bad. Shit, this is very bad. TO, and I also have to take care. And I would also see if not LO, last one was not O, then it means I have come from a place where there was W on the left. So total W minus 1, total W minus minus, total W minus minus, right? And something else? No. Also bring this thing after, right? So this should work because of the thing that I did above. And I have to also push back to the number of O's that I have currently, which is current O. And in here, after this, I have to increase the number of W's and the number of O's, number of W's only. Number of W's would become this. Current W's, but I do not actually care about current W's. I only care about total W's. Yeah, so I only have to increment the total amount of W's that I have seen, TW plus plus, because I just saw AW. Okay, and now, and at the end, if I am in a string like this, at the end I would have, will this algorithm work on this? So, it's fine, 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 fine. LO would be true initially, so this thing would push back 0, 0, and then LO would become false, and current O would become 0, and total W would increment by 1, and current W, which I do not even care about, would also increment by 1. Then I will go to this place and I have to change the state of LO. LO equals not LO. Okay, so this would make it 2, this would make it 3, and then I would come here, and when I see this O, I would increment the number of O's. It would become 1, and I will see that the last one was not an O, so I will decrement my number of W's and increment this. Then when I see a V next, I'll see that the last one was an O, so I push back W so that I know for the last O I have added the total number of W's that O has on the left, and the total number of O's for that specific O. That makes sense. That makes sense. And then for int I equals 0, I less than O dot size and I plus plus, and for every O, let's say int answer initially is 0, and answer plus equals number of W's on the left. Number of W's on the left would be W left for I multiply by OI multiplied by W's on the right, which would be total W minus W left. But I have to see something. When I come out, either the last thing was an O, and if it was, then I already did this thing. And if it wasn't, then I have to do total W minus 1. If S dot back isn't equal to, if S dot back not equal to O, if it wasn't equal to O, then total W minus 1. And I think this should work. Or this might not work. Shit. Okay, what do these things have? C out total W, C out O, and then total W, then line. Hang on. Y is if LO, if LO is true because I am stupid. Because, okay, 4 is cool, 4 is cool, 4 is cool. Six. We found the first time I have nothing on the left, so 0. And then for the second, it should be 2 multiplied by 1 multiplied by 4 minus 2. Why is it not so? Okay, low battery, I have to plug this in. That is extremely low battery. I think, bro, you should work more on implementation and to write code in a better and clean way such that it covers all edge cases and no need to take care of each condition every time. So implementation, okay, I will work on my implementation. Like I am working on my implementation skills. And no need to take care of each condition every time. No need to take care of each condition every time. And if I think I do not understand that part, no need, because I have to take care of edge cases, which is important. Taking care of edge cases is important. But I think that is not what you mean by every condition. Yo, new line. Okay, so initially it was I outputted the whole thing 4, then it was 2, and then it became 6 due to some reason. Double I because okay, cool, 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 cool. And this should work now. 1600. I will also reach 1600. Right, yeah. Not yet 1600, 1452. 1452 is also impressive. And 1583. I have a friend whose maximum is 1499. And okay, shit. This is good. This is good. 47 minutes for a single question. Okay. But this one was very easy. This one was very easy. This one was easy. I mean, posthumous is it does seem easy, but while doing it, it didn't seem very easy. Bot Durgesh. Okay, we can look it up right now. That's cool. Bot Durgesh one. Let's see. I do not have a lot of friends who do code forces, so this is cool. Uh, Visakhapatnam. Shit, shit, that is cool. Shit, 551 in your first contest. I got 540 in my first contest. And then 600, even higher than that. Okay, so that is actually cool. And this is not even very far ago. So that is cool. And you have done 500 questions. Okay, and you have a lot of friends. Social guy. And then you have done 32 contests. Okay, and you reached your maximum at this point. Okay, you reached your maximum right at this point, 15. Okay, when did you cross the 1400 barrier in your fourth contest? Okay, shit, I won't be able to beat that. But when did you cross your 1500 barrier for the first time? In your 18th contest. I am currently at my 10th contest. Okay, can I beat you? Okay. Do I want to take a challenge? I am currently at my 10th contest, and shit, this thing right here, this lower part is very impressive, very impressive. Like you reached this high, that is cool. In your third division, you were able to do 5 questions, and what would the time be for these questions? Shit, that is a lot of time. Right. Even what? So code forces doesn't work at times, which is bad. And I have installed this new thing, not installed, I have found this new website in which I can do little mental math quizzes. Let's say easy single player, classic 2 minutes. So I have to do this thing, stuff like this, I, which helps, I guess, which can be tricky at times. Whoosh. Mm, shit. Why does this feel very hard? This, uh, shit, 48. My bad, my bad, my bad. I feel like I have my life on the line here. Why does it seem so hard? Okay, demonic noises. 23. Shit. Eight, 80 plus 8 fours are 24, 104. Shit, why do I not know this? 32. Oh, come on. Shit. Yes. So I need a lot of practice. I need a lot of practice. Shit, 41. Shit. That was very embarrassing. I should have stuck to code forces. 1530 in Division 2. I haven't gotten a rank that good. And this is very cool. This is very cool. You did the first one in 5 minutes. Were you doing DSA and stuff before this, before you were doing this? Because this is very impressive. Do you do code stuff or lead code? I do lead code from time to time from the neat code roadmap. This thing. This is cool. And yes, mostly code forces. And my ID and CC code chef and lead code is bot Durgesh. That is very cool. I can look it up. Well, now at least I have someone I can compare myself with and feel good and bad. I now have at least a target. That does sound worse than it is. Wait, Eliona. I thought it was Eliosha. Eliosha is amazing. Shit, Eliona. And I would like to now rest and end the stream. Rest is not the right word, but take a walk. I would like to take a walk and get back in some time. And yeah, it's cool. And thank you for being here.